Dear learners, welcome back to NPTEL online certification course on novel drug delivery systems. I am Dr. Satish Devanapalli, working as a assistant professor at Department of Pharmaceutical Sciences and Technology, Institute of Chemical Technology, Mumbai. So, in this week we started controlled drug delivery systems. In that we are discussing the approaches to design various types of control release drug delivery systems. So, in our previous lectures we have discussed on the general design consideration, key factors and the strategies to design control release drug delivery system, and then we have discussed the drugs which are not suitable for control release drug delivery systems. In our previous lecture we have started our topic on the approaches to design control release drug delivery systems, and then we have discussed the classification of control release drug delivery systems, and in that we have discussed the dissolution controlled drug delivery systems. So, today we are going to discuss on other two aspects, that is diffusion controlled drug delivery system and another one is dissolution and diffusion controlled drug delivery systems. So, in our previous lecture, so we have classified based on the release mechanisms, just we will see the overview of the previous session, and yes, we further classified dissolution systems into reservoir systems and the matrix systems. As we know that, so dissolution is one of the rate limiting step for the absorption, and yes, the dissolution is very important parameter for all the dosage forms. Whenever you deal with any water soluble drugs, such cases your drug release should be controlled with the desired polymer, and that will should undergo the slow drug release, which are very essential. And we have seen the two mechanisms by the reservoir system, that is the encapsulation system, and then we have seen the matrix systems, and here the drug is the embedded or dispersed with the polymer as in a matrix, and the control release is possible with the matrix systems. And these are some examples we have seen in our previous lectures, and this is the one market product for the matrix dissolution control systems. Yeah, today we are going to discuss on another release mechanism, with this help to design the control release formulations. So, the topic we are going to discuss today on the diffusion controlled drug delivery system, and we know that diffusion is very important for the absorption. So, as we know, the diffusion is nothing but movement of the molecules from high concentration to low concentration through semi permeable membrane, which is called as diffusion. When it reaches the equilibrium, when both concentration will be equilibrium, then the diffusion will stops. So, this mechanism is very important for the absorption. So, this, and here there is no energy is required for the diffusion, and such mechanism can be performed by using the inert water insoluble polymers as a membrane. When you encapsulate or when you trap or when you coat or when you embedded your drugs in a inert water insoluble polymers, and that will follow the diffusion controlled drug delivery mechanism. And yes, as we discussed in case of dissolution, with this in the diffusion control we can make as in a reservoir systems, and with this we can make a monolithic matrix systems. As we discussed, these systems will follow the diffusion, and we know that the drug release is governed by the Fick's law of diffusion, and yes, that is very important for any type of the dosage forms. And the rate limiting step in diffusion control system is the diffusion of the drugs from the polymeric membrane. So, once your drug will diffuse from your membrane and the maximum of drug will absorb through the biological membranes. So, the rate limiting step and the mechanism is the diffusion, which is not required any energy. As we discussed, this can further classified into the membrane controlled drug delivery systems and also monolithic matrix control systems. In the picture you can see the two different systems. So, here you can see the drug which is encapsulated in the non-porous polymer membrane. In another side you can see the same drug which is dispersed in the porous polymer membrane. So, yes, here in case of porous polymer, the biological fluid when it will interact, so it forms the porous. With that the reservoir system will influenced by the aqueous membrane, by the aqueous fluid in the membrane, and then it will help us in the release of the drug through these pores. And whereas in non-porous, so when polymer will degrade, so our drug also will release based on the degradation of the polymer. And here in another image we can see which is monolithic matrix control systems. So, drug dissolved in the polymer and the drug dispersed in the polymer. Here by using of these polymers or monolithic systems or matrix systems, we can dissolve the drug in the polymer and we can make in a matrix system, and in other cases we can disperse or we can make in a matrix system by using the polymer, but there your drug will not dissolve, and you can see the performance in the diffusion of the drug. So, here you can see, so you can see the layer of the polymer and slowly your drug is coming out from the system, and here also you can see the polymer will remain same and your drug is releasing out. So, here so drug is dissolved in the polymer, both polymer and drug will release slowly, whereas here the drug is dispersed in the polymer and the drug is coming out through the diffusion mechanism. And further details we can see the difference between the reservoir systems and the monolithic matrix systems. Here in reservoir system we can easily achieve the zero order release by using the various types of the polymers, whereas in monolithic it is very difficult to achieve the zero order release. These reservoir systems or the degradable systems may be difficult to design, that is one of the major challenge, but performing various optimization studies by playing with the process control parameters and by utilizing the various concentration of your polymer and the drug and with different technologies or different steps which are involved during the preparation, with that we can achieve the reservoir system, right. So, and in case of monolithic and matrix system which are suitable for degradable or non-degradable systems. So these have, we can use both degradable and non-degradable systems. Rupture can result in the dose dumping. Also we discussed same point in our first lecture of control release drug delivery system. So dose dumping is one of the major problem in the controlled drug delivery system, because the designing is very important. Any changes happen with your dosage form in the body, what happen, your entire drug, full amount of the drug will come out from the system, which is called as dose dumping. That leads to lot of side effects, and it will not show any right release and right action in the body. So such cases we need to perform various optimization steps, and here also no danger of the dose jumping. So here in this case we are getting more advantages compared with the reservoir systems, and the drug inactivation by contact with the polymer matrix can be avoided, because that for that you need to perform various compatibility studies. From that you will understand which polymer is suitable for your drug. By doing that, your polymer should not inactivate your drug. That we need to consider during the selection of polymer. Not all drugs can be blended with the given polymer matrix. So here there is the limitation, we cannot blend it with some of the drugs which may interact with the polymers in case of monolithic or matrix system. Such cases we need to look for the right polymers for designing of monolithic or matrix control systems. So here in further we can see with this graph we will understand how these diffusion control systems will help in the designing of the control release formulations. Here you can see drugs loaded in the system before release at time 0. So here the maximum amount of the drug is available for the release. You can see, right. So maximum amount of the drug available before the release. So at the time 0, you will see the maximum amount of the drug is loaded in your systems, right. So and partly the drug is released at the, by the diffusion at the time t1, this is 0, at the time t1 and at the time t2. So now you can see when time goes in the dissolution or in the after administration, your drug will release. You can see the drug is releasing at different time intervals, right. So now these systems, these two systems, reservoir systems and the monolithic or matrix systems, are the two diffusion systems. Again in that we can see two different varieties, right. So here the non-constant drug sources, and also you can see here also the monolithics also comes into the same category. And now here is the constant drug source and here is the monolithic dispersion. Now you can see in this case the drug precipitation or aggregation is very high, which are shown in the red color. So you can see here, so in this case in the constant drug source you can see the drug is precipitating, that is mentioned non-dissolved drugs or dispersed aggregates, which will show the control release. Now we can read the text in non-constant drug source reservoir or monolithic solution systems, drug concentration in the system reduces over the time. Now you can see the figure 1 and then 2. In both non-constant reservoir and monolithic systems, your drug concentration in the system reduces the over time. Now, you can switch it to time point 1. Now, you can see the drug is releasing, the drug concentration is reducing over the time, right. That is happened at this figure and this figure. Now, when you go further from 0 to T1 and T2, you will see the drug is, the percentage of the drug is very, very less in case of this compared to this, and similarly compared to this the concentration is high, right. So, whereas in constant drug source, by you seeing the name the constant drug source, here what happens in case of either it may be reservoir or monolithic systems, the dissolution of the undissolved drug aggregates, that is represented in red color, over the time ensures the continual drug release while maintaining a constant concentration of the drugs within the system for a prolonged period of time from time 0 to time T12 and T2. So, now you can see, if you see the T1 and T2, now you will see here the maximum amount of the drug which is available in the system compared to this, and which is already aggregated form. So, that will help us for the continuous release through the diffusion control release mechanism, and these polymers are the water insoluble polymers and which are inert in nature, which will help us in the diffusion of the drug release. So, with this mechanism we can design various types of the diffusion controlled drug delivery systems, and these are the 2 marketed products which will follow the diffusion controlled drug delivery systems. And the first product is Nitrodur, which contain the nitroglycerin and which can use for the angina pectoris. Whenever you have a high blood pressure, such cases we can use it for the treatment of the angina pectoris. Of course, such cases we need to control the blood pressure, and that need to be within the limit. So, this is the type of the matrix type transdermal patches. The brand name is Nitrodur, and which contains the dose of the 0.4 mg per hour, and yes, it will follow the diffusion principle, and these patches we need to place on the skin, and over the time the drug will release and it will undergo and it will reaches to the blood through the skin layers. So, yes, in case of transdermal and topical applications, so the matrix type transdermal patches can be prepared. With this we can give the patient compliance, also we can expect the patient safety also. And the another one is the Duragesic. It is again the reservoir type transdermal patches, and this also release the drug through the diffusion, and this can also use for the chronic pain management, which the drugs comes in the class of opioid drugs, and the dose is 100 microgram per hour. So, with this we can expect the control release at a predetermined rate, and such type of product will improve the patient compliance as well as safety of the patients. And not only that, we can by using the control release systems we can reduce the side effects, and not only that, we can reduce the number of frequencies for the administration of the drugs. In a third system, we are going to discuss the dissolution and diffusion control drug delivery systems. So, it is a combination of the both mechanisms. So far we have discussed on the dissolution and diffusion control system, and these systems we works on the principle of the combination systems. In dissolution and diffusion combination systems, so the drugs are trapped in partly insoluble polymeric membrane or matrices that will dissolve to create the pores, then it will follow the diffusion principle. So, two principles are followed in this system. These pores already we have discussed, the pores allow the aqueous mediate flow into the core of the system, then that will undergo the diffusion and your drug will release out from the system. So, that can be represented here. Now, you can see this is the system of the dissolution and diffusion control systems. It follow the Bose system, the entry of the diffusion fluid, dissolution fluid and the drug and the drug dissolution. So, here we can see the two mechanisms, that is by using dissolution and then diffusion, and this is the pores created by the dissolution fraction of the soluble membrane, and here also you can see the insoluble membrane. With this we can maintain two mechanisms. So, some cases it may follow only one mechanism and some other cases it will follow the combination of two mechanisms. If you use there are the cases there it may one mechanism can be dominant over the other mechanism. So, such cases we need to optimize the formulation, that is very important, and which may be the dissolution rate limited or the diffusion controlled release systems. So, these combination systems also will be helpful for the chronic treatment also. So far we have discussed on the various approaches to design controlled release drug delivery systems, and we have discussed on the classification of the controlled release drug delivery systems, and we have discussed on the dissolution controlled release drug delivery system, and further we have discussed diffusion controlled release drug delivery system, and in the last we have discussed combination of the dissolution and diffusion controlled release drug delivery systems. So, in our upcoming class we are going to discuss on some other approaches which are very important during the design of the controlled release drug delivery systems. So, with this I am going to stop today's lecture. Thank you so much.